Right, welcome back, grade 11s. We're looking at Unit 4, the stoichiometric calculations. And in the stoichiometric calculations, there are specific steps that we have to follow. Now, if you look in your textbook, this is on page 185. And the steps are listed for you on this page on exactly what you need to do. We also have a method that we are using, and we'd like you all to do the same type of thing. So please use these steps when we are looking at this. Now, first of all, what is stoichiometry? In your passage here on page 185, it tells you that when chemists in pharmaceutical industry develop medicine, they need to know how much product will be made from a certain amount of reactants. They cannot just throw things together and hope they're going to get some miracle. They have to do it with calculations to know exactly what needs to react with each other. And they do exactly what we do here, that they do in that situation. Right, so there are some words that's important here. For example, excess is the amount that is more than necessary. A reaction that runs to completion is one that is one of the reactants is used up. Then there's also an experiment that is done. It's always a good idea to go and read through the experiments that's in your textbook, because they're referring to methods and that is important for you to know. There's also some writing of formulas that you can practice on page 187. And then we get to this activity on page 188, which we'll talk about now. Right, so looking at the unit 4 then, the stoichiometric calculations, if we go to the notes that we have, we see there that we do have the steps. Step 1, write the balanced equation. Step 2, write the mole ratio from the equation. Step 3, write out the number of moles of the given compound, or work it out. Then you're going to go and work out what will be the new number of moles that forms, and then you're going to basically answer the questions. Now, the 3 examples that we have, I've already given you the answers, so I'm not going to do them again because you do have the answer. So find the mass of the water. In your notes that you had to prepare in the previous section of work, you have these answers, and you can see exactly step by step what is happening in order to find this. There's the answers to number 2, the answers to number 1 and 2, and there's the answers to number 3. Now, after consulting with 1 or 2 of the grade 11s, I did ask them if they went and did the work, and they said yes, and we looked at 3 questions that was more difficult than the others, and that is the ones that I'm going to focus on. Right, so the first one is then activity 2, page 188, number 6, and this one says, ethanoic acid reacts with ethanol, produce ethyl ethanoate according to this reaction, and the reaction is given to you. Determine the mass of the ethanoic acid and the mass of the ethanol that is needed to produce 100 grams of ethyl ethanoate. Assume that the reaction goes to completion. What does that imply? That implies that one or both of the reactants was used up in order to form the product. Right, so that is a reaction that runs to completion. So where do I start? I start off with step 1, and step 1 is write a balanced equation. Now we have the equation here, and if I quickly go and count carbons on the left hand side, 1, 2, 3, 4, carbons on the right hand side, 1, 2, 3, 4, so the carbons are balanced. Next, I balance non-metals. There's no non-metals. Hydrogen, 3, 4, 9, 10 on this side, 3, 8, 10. So the hydrogens are balanced. Oxygens, 2, 3, there, 2, 3. So this is already a balanced equation. So everything reacts in a ratio of 1 to 1 to 1. That is step 2 according to our steps that I just referred you to. That in step 2, we write the mole ratio from the equation. Step 3, work out the number of moles given of the given compound. Now the given compound here is the ethyl ethanoate, and we have to go and convert that now to number of moles. So to convert number of moles, So step 1 was done. Step 2, to convert the number of moles, I'm going to use number of moles is mass over molar mass. Right. Now the molar mass of that ethyl ethanoate. So I have to go and calculate the molar mass of CH3CO2 C2H5. So there's 1, 2, 3, 4 carbons, and 4 carbons each has a mass of 12. There's 8 of the hydrogens, and hydrogen has a mass of 1, and 2 oxygens, which has a mass of 16. So that gets me to 88 grams per mole. Right. So 100 grams of this with a mass of 88 is going to give me a mole of 1,14 mole of the CH3CO2C2H5, the ethyl ethanoate. Right, so that's my step 2. Step 3 is then, or the next step is then, multiply by want over got. Right, now there's 2 things that we have to go and calculate. We have to go and calculate the mass of the ethanoic acid and the mass of the ethanol. So step 1 and 2 for both of these are exactly the same. But then we're going to work here with ethanoic acid. And on this side, we'll do the ethanol. Right. So the step for the ethanoic acid is my ethanoic acid, which is CH3CO2H. I put in ratio with my ethyl ethanoate, CH3CO2C2H5, and I see the ratio is 1 to 1, which implies that the number of moles of the ethanoic acid will also be 1,14 mole. Right. That was not what was asked. What was asked? The mass. So step 5 is then work out that mass. And I work the mass with mass is equal to number of moles times molar mass. 1,14 times. Now the molar mass of my ethanoic acid, there's 2 carbons, each with a mass of 12, plus 4 hydrogens, that must be a 3, 4 hydrogens, plus 2 oxygens. Now doing this calculation, you find your answer is 68,4 grams. Now the answer in the textbook is a little bit different, and the reason being is the periodic table that we use, the one that we give you in your exams and tests and everything. This one is a rounded off version of the one that is in your textbook. So the textbook use different atomic masses, and that's why the answers are not exactly the same. Right, so don't let that confuse you. It is within reason the same answer. Right, then for the ethanol, what was the ratio for the ethanol? Now my ethanol is C2H5OH. We put that in ratio with the same ethyl ethanoate, 2C2H5. So that is also in a ratio of 1 to 1. So my number of moles of ethanol is also going to be 1,14 mole. That is going to be required to make 100 grams of ethyl ethanoate. It was mass that was asked again, the 1,14, and now I have to go and work out what is the mass of the ethanol, and the ethanol has 2 carbons with mass of 12, 6 hydrogens with a mass of 1, and 1 oxygen with a mass of 16. Doing that on my calculator, I then find an answer of 52,44 grams. And there I've answered the question. Step 1, balance the equation. Then you can look at the ratio. Step 2, convert what is given to number of moles. Step 3, look at the ratio of what you want and you got. Step 4 or 5, go and calculate what is what was asked. Always go back and make sure that you answered your question before you just carry on. So we were supposed to go in mass of ethanoic acid and ethanol. We did do both. Right. The next one that was also a bit more difficult. Same activity, page 188, number 7. Right, so for number 7, this time they don't give you a balanced equation. And can you see now why is it important that you must be able to write formula? You have to be able to balance equations. In the reaction between calcium carbonate, now calcium carbonate, CaCO3, with nitric acid, HNO3. The products are water, H2O, carbon dioxide, CO2, and calcium nitrate. Now, calcium nitrate is going to be Ca bracket NO3 close bracket 2. Determine the mass of the anhydrous. Anhydrous referred to, there's no water trapped within the crystal. Calcium nitrate and the volume of the carbon dioxide. So again, two things that was asked. That is produced from 3,33 grams of calcium carbonate. Right, so that's my got. That is what I have. So step 1. What do I need in step 1? I need a balanced equation. So CaCO3 plus HNO3 reacts to form, and we have, now we're not going to put water first. We put that, and then CO2, and then H2O. Right. Balanced. First is the calcium balanced, yes. Carbon balanced, yes. Nitrate balanced, no. To balance it, I put a 2 in front of it. That made no change to the previous one, so we can go on. Hydrogen balanced, yes. And there we have a balanced equation. Next step, I see that my ratio is 1 to 2 forms, and all of the others form 1, 1, and 1 mole. Right. Then we have to go and take what we were given and convert it to number of moles. So we were given that calcium carbonate, we got, that is our got. So my number of moles of calcium carbonate is going to be mass over the molar mass of calcium carbonate. My mass is 3,33, and the mass of calcium carbonate is, calcium is 40, plus carbon is 12, plus oxygen is 16. Now that's work out to be 100 grams per mole. And I substitute it into that spot there to get 0,033 mole. Right, now the calculator says 0,0333, but this is significant numbers that we can deal with. Right, so we're all at the step now that we know what amount of this I have. Right, they're not asking us anything about the nitric acid, so we're going to assume there's enough of that, and all of the 3,33 grams of calcium carbonate is going to be used up. Right, so the calcium carbonate is the one that's going to determine how much of the product is forming, and there's enough and excess of nitric acid so that it's not affecting the amount of product that is formed. Right, we can go to the next step, and the next step says go and work with the ratio values. So my number of moles of calcium carbonate, 2. Now, but determine the mass of calcium nitrate. Now, the calcium nitrate, looking at my balanced equation, the ratio is 1 to 1. Now, since it's 1 to 1, what number of moles of calcium carbonate will form? It will be not calcium carbonate, calcium nitrate, 0,033 mole of that will form. Right. But that is not what was asked. What was asked determined the mass of it. So I need to convert the mass, and the mass is equal to number of moles times molar mass. So 0,033 times Now the molar mass of calcium carbonate, 40 plus 2 times 14 plus 6 times 16. Now I've already worked it out, so you can go and check me, but that works out to be 164 grams per mole. Substitute that in my calculator and I get 4,92 grams of calcium nitrate. Right, and yes, I'm done with the mass, but I did not answer everything yet. The other thing that I have to do is to go and calculate the volume of the carbon dioxide. Now I don't have to redo step 1 and 2, I only have to follow on from step 3. So for step 3, my number of moles of calcium carbonate to my number of moles of carbon dioxide is also a ratio of 1 to 1. So my conclusion is that the number of moles of carbon dioxide that's going to form is going to be 0,033. Right. I'm working with volume and I'm at STP, which implies that I can use the number of moles is volume over molar volume. 0,033, the volume I want. And what is the molar volume at STP? 22,4. If I manipulate this formula, I find that I have 0,033 times 22.4, and I get an answer of 0,67 cubic decimeters. Right. If I only take the 0.03 times 22.4, I get 0,72, and that is what is correlating with your answer. Right. So if we have used two significant numbers like that, and not 3 as I did here, I get 0,67 cubic decimeters. Go back, did you answer everything? Determine the mass, yes. Determine the volume, yes. And we're done with this question. Right. The last one I'm going to do as an example for you is the revision and extension page 208, number 8. Right. That was also a different type of way that this question can be asked to see if you understand the concept of stoichiometry. Let's read the question. An unknown metal X reacts with sulfur to form a compound with formula X2S3. If 3,12 grams of X reacts with 2,88 grams of sulfur, what are the names of X and X2S3? Now the hint that they give us, determine the number of moles of S and use the formula to find the number of moles of X. Right, now how do I identify an element? I can identify an element by its atomic mass. So the question basically asks me, go and calculate the molar mass of X so that you can identify it and then give us the name. Right, so let's go. There's always steps to follow. What is step 1? Step 1 is write a balanced chemical equation. So what reacted here? X reacted with sulfur and it forms X2S3. That is everything that I read from here. Right. Sulfur is a solid, it's not a diatomic molecule, so sulfur will react just as sulfur. Right. It's a formula, but it's not balanced yet. There's a 3 in front, behind the sulfur. The only way that I'm going to fix the problem is if I put a 2 in front of the compound. 2 times 3 makes it 6, so I need 6 of this, and 2 times 2, 4 of the unknown compound X. And now I have a balanced equation. The ratio, therefore, 4 of X reacts with 6 sulfurs to form 2 of my new compounds. Right. Step 2, use the hint, number of moles of S. So we want to go and find the number of moles of S, which is mass over molar mass. My mass of the sulfur, 2,88. and the molar mass of sulfur I found on my information pamphlet is 32. 2,88 divided by 32, 0,09 mole. Right. Now I'm going to go to step 3. And step 3 says, put these two in ratio to each other. So my number of moles of X to my number of moles of sulfur is 4 that I get there to 6 that I get there. Right. Now I don't know this one, but I do know that I've got 0,09 of that. So to find my number of moles of X, I say that it's the number of moles of sulfur multiply want over got. Now what do I want here? I want my X and I got my S. Right. So I'm going to put 0,09 because that's what I know from there. My want is 4 and my got is 6. You can also see that it works like that. Right. Working that out, I've already done that, gives me 0,06 mole of X. Right. So this is step 3 that I've now worked out how many moles do I have of X. So my next step is now to go and find what is X. And to know what is X, I need to know what is its molar mass. So I'm going to use number of moles is mass over molar mass. So the number of moles of X, 0,06, is equal to 3,12 that I found here, divided by the molar mass. After manipulating the formula, I get 3,12 divided by 0,06, giving me 52 grams per mole. Right. And now I go and use my periodic table and I find 40, 48, 50, 52. Right. So what is X? So therefore, X is CR. And X2 is 3 is CR2 is 3. Which is now identifying, but did you answer the question? The question is, what is the names? So you will not get all your marks if you don't go and give the names. The name of CR is chromium. Right. And therefore CR2S3 is going to be chromium 3 sulfide. Right. I hope that helped you in getting to these answers and just revising what is the method that we follow with the stoichiometry. Right. In our next lesson, we are going to look at limiting reagents. So it will be advisable if you go and read through that before we look at that lesson. Thank you, grade 11s.